Good morning, good afternoon, good evening, wherever you are in the world. Thank you so much for joining us today. My name is Sarah Alspaugh, and I will be your webinar host coming to you from Cincinnati, Ohio, here in the U.S. I'd like to welcome you to today's webinar. Our topic, Strategies to Streamline Product Innovation by Managing and Optimizing Product Variations. And I would like to welcome and introduce our speaker for today, Jamie Wilkins. Jamie is currently a Teamcenter Marketing Manager with over 25 years of experience with MCAD and product lifecycle management tools. Over the last 20 years with Siemens, he has also held roles in professional services, education services, and pre-sales solution consulting, assisting customers across multiple industries throughout the world with the use and success of Siemens solutions to solve their business challenges. Welcome, Jamie. We're very excited to have you here today. I'm going to go ahead and make you presenter here.
Like Sarah said, good morning, good afternoon, good evening, depending on where you're at today. Thanks for joining the webinar. We're here to talk about a new approach to greater product innovation for your business, leveraging the power of the Siemens Digital Industries software portfolio. So we're here today to talk about an integrated approach to engineering process management, and specifically how it relates to configuration and variability management. Let's get started here. So let's talk about some challenges on becoming a digital enterprise. So regardless of the industry, a common trend impacting every product developer is that products are getting more complex. And they're comprised of mechanical, electronic, and software components. And so do any of these issues sound familiar to you? Schedule delays and poor market acceptance or non-compliance because your requirements weren't tied to the product design or delivery, or design teams that can't seem to find or reuse the right design information when they need it. Or how about tedious design review processes and the late discovery of issues? And of course, the later those issues are discovered, the more costly it is to change them, and sometimes even the more difficult it is to change them. And slow or error-prone change processes that fail to account for cross-domain impacts. So if you're seeing any of these issues, it's time to rethink your approach to product development and face the challenge to become a digital enterprise. Now, there's different steps along that journey to become a digital enterprise, and so we can help you with some of those challenges that you'll face along the way. Now, we're not suggesting that you have to revolutionize your business overnight, but we are offering and talking about is a roadmap. So a roadmap that helps you take those steps, those first steps along your journey to digitalization. So we can help digitalize your business with our fully integrated approach to engineering process management. So in essence, collaborative product development across systems and domains and departments, which can help you accelerate product innovation, improve product quality, and streamline the handoff from engineering to manufacturing. Now, if we take some of those things from the previous slide and break them down into solutions that we offer, so we have a variety of solutions. We have solutions that can help ensure compliance by connecting your requirements to product development, or support cross-domain design management through integration of tools and data and processes, which help you find, share, and reuse the information. Or define and share a complete understanding of the product and its variants that streamlines that transition to manufacturing. Solutions help eliminate late-stage rework by visually collaborating to discover and correct issues. And also reducing delays and improving quality with configurable closed-loop change processes. Now, I think you would all agree that each one of these, they're very important, and they're also complement each other. So they're very connected. So we're not going to talk about all these today. Purpose of today is to talk about variability management. But we have other webinars. So we have a series of webinars. This is the 5th live webinar that we've done. We have a 6th one coming up next month. And we'll talk a little bit more about how you can access the other ones where we talked about these other solutions as well. So as I pointed, today we're going to focus on variability and configuration management. So let's look at the importance of establishing that common bill of materials, or BOM, across all configurations of the product and its value to manufacturing, because manufacturing needs some of those same exact configurations. All right, so if you've attended some of these webinars before, the way this process will work is we'll set up some challenges. We'll talk a little bit about how we can solve those challenges, and then we'll show a couple of videos that help highlight that and show that in action. Along the way, there's be some time for some questions at the end, And as Sarah indicated, you can enter your questions in the chat window. We'll try to address some of them during the call, but we'll also follow up with you afterwards with answers to your questions. All right, so let's get started. Talk about some challenges. So some research out there by EMS, it's a manufacturing services provider, and they indicated that a major impediment to smooth transition to manufacturing starts with that BOM, that bill of materials. And so they found that 80% of BOMs contain errors. 40% of them have part errors, or inconsistent content, or even invalid supplier data, or missing info. And even worse, 8% of BOMs had obsolete parts on them. And so the issue often had its root cause tied to, well, one thing, a multi-domain design process that's generating an incomplete bill of materials. So electrical and mechanical software not working together. A lack of shared understanding of the product configurations and all its variants, part of the reason we're here today to talk about solutions. And differing global design and manufacturing processes that are not able to access and analyze the information easily so they can properly prepare and optimize their processes. And as you can see at the bottom, that's a quote by the Aberdeen group. So those that fail to adopt good BOM management practices risk adding to inefficiencies and delays. And so organizations trying to adapt to the growing complexity of their products should look to address the challenges of BOM management. And so in this case, it's more BOM management with the variability that's applied to it. All right, well, those are the challenges. Let's look at some of the trends in the industry. So we just talked about complexity of products. Well, guess what? Products are continuing to get more complex. So it's not so easy anymore for an engineer to see the impact of their work now that it's in a complex mechatronic environment. So interfaces between the disciplines of mechanical, electronic, and software are very strong. And so you got to better work across those domains to understand if this thing changes, how does that impact the other domains? So a piece of software changes, how does that impact the performance of the product? There's more choices. Customers demand greater individuality. And sometimes to compete with low-cost production competitors, some producers are offering a higher variety and therefore some lower cost price points, and they're starting to remove unneeded features from a standard product. Now, managing all this variability, you obviously want to try to do this without adding costs. So you don't have to drive up the costs higher for variety, which ends up reducing some of your margins. So this requires a nice automated engineering and production use cases, which can't get slowed down as some of those lot sizes decrease. There's multi-function teams, so there's many contributors that contribute to the definition of a product. So it's not just the job of a single product manager anymore. So those products are based on platforms and product lines, and maybe marketing drives the model management and a sales strategy. And so this needs to be defined centrally and then used downstream through engineering and manufacturing and service throughout that whole life cycle of the product. Related features, so there's a complex network of features and constraints. So a consistent feature set is the outcome of a nice product or a proper product planning process. And so rules help engineering limit the complexity and analyze and make better decisions. And visualization and analysis. So being able to visualize that product throughout the life cycle, early on when you're trying to define it, and all the way through manufacturing, production, and service. So marketing wants to visualize combination of features early in the process, like I mentioned. And engineering wants to validate the results to get multiple variants. And production wants to validate if the specific variants are even producible. And do these parts even fit together? Or is there a collision or an interference in the tooling that they have? So visualization becomes important in this. And so the trends on this slide, in essence, drive the need for variant configuration, being able to manage the variability of your products. Well, let's look at some of the different types of variability that are in products. So if we look from the left to the right of the screen, you start off with some standard products. Things that are more high volume type products like a phone or a camera or a drill or a laptop or maybe a vehicle. And as you move over to the right-hand side, you get to more specific, not only low volume production runs, but even more one-off runs. And so from the left to right, you move from just configuring kind of which part numbers make up the product, so to engineering brand new parts for sometimes production runs of only one. So maybe that motorcycle over on the right, that may be unique. That may be the only one out there that was engineered specific to some requirements. Where a phone we probably walk down the street and you can probably see people that have the same phone as you do. Maybe it has a different memory size in it, but overall it's the same exact phone. Now for standard products, there's two common approaches. So one is just start from a design and iteratively derive additional standard products over time, increasing the size or the capacity or maybe adding a couple additional features. The others, you can define a platform up front which configures those specific standard offerings. And as I mentioned, electronics and consumer goods are often a good pattern that these follow, as well as some machinery, maybe more high volume type manufacturing objects or items. CTO or configured order. So really what you're doing there is just determining what parts go into this configuration. You're typically not engineering new parts. It's mainly here's some approved list of configurations and some parts that go into that configuration. You answer a bunch of questions, and that determines what your configuration is going to be. Now, a lot of times the theoretical combination of those product configurations is so large that it's impractical to configure into standard products. So if you've ever tried to order a vehicle, there's how many different configurations of that vehicle when you start accounting for things like the color, the wheel sizes and engine sizes and option sets. Even though the manufacturers try to limit them, there's still almost infinite ways to configure something. Now, so all these products can be built without engineering any new parts. So you're basically just saying, what's the configuration of it? Oh, it's part 1, part 2, and part 3. There's a configuration. Now you just start moving over to the right, more engineering to order. That's where, based upon requirements, you typically are engineering new parts. So maybe it's something for a low volume production run where engineering solutions in advance may not be practical. Maybe a specific type of machinery that has to do a specific task that may be one-off, not something you see a lot of them out there. Or there's a site-specific application where there's specific requirements for how that product needs to either fit into the through the door or how it's going to be positioned on the floor or whatever it may be. So there's flexibility in modeling that's necessary. So typically along engineering to order, you're engineering new parts. You're having to generate new part numbers and new solutions to come through and figure something out. Now, there could be a blend. There might be, well, some of it is configured order. Some of it we have to engineer to order. So there definitely can be a blend along the way where maybe there is some uniqueness to that, but generally it's pretty common to a CTO use case. And we'll talk about how we have a handoff between there. And then you get over to the custom product side, and that's generally more of a, if you can dream it, we can build it. So those are the one-off type things, like you can see that table, that piece of wood, the chances of you finding that slab of wood that looks just like that are pretty slim. Obviously trees are all different and so forth. And same with that chopper. That's probably a one-off, maybe 2 or 3 of them, very low production run, but engineered to that specific customer's needs. All right, so that kind of gives a kind of a preview or an overall view of what the complexity spectrum looks like. Now, from a Teamcenter standpoint, so although we offer solutions in a seamless fashion across that entire product spectrum, so the focus of the presentation today is mainly going to be around Teamcenter Product Configurator. We'll highlight a little bit about Variant Matrix, highlight a little bit about RuleStream. So those CTO, those configured order products, so they have a large number of parts, and when combined in an assembly, create a complicated system. And so those sheer possible configurations or combinations, I should say, requires a tool not only to create the combinations, but also manage them over time. So basically, we got a high number of parts, lots of complexity, and constraints between those features to determine whether to include or exclude that product from the configuration. So like I said, that's the main focus today is Teamcenter Product Configurator. Highlight a little bit about Variant Matrix and a little bit about RuleStream as well. All right, well, if you had to lay out your needs, so companies need a solution that enables to manage that complexity from product inception, from the time you're starting to plan what this product's going to look like and how's it going to perform and what other requirements that go into it, all the way from manufacturing and even service, in a simple way that enables reuse and commonality and eliminates some of those engineering cycles on products that are never even going to be offered in market. So we lay out some needs here: single source repository, scalable across at an entry level. It's got to scale to your particular needs and the size of your bill of materials. Being able to represent the 3D product, so being able to come through and capture that geometric information of what that product's going to look like. Being able to verify along the way. Part of that is with some of the visualization and other tools that we have. and be able to maintain your data by the particular function that it relates to. So these are some of the needs that if you were a company that set out, here's what you're looking for. Well, Teamcenter Product Configurator has been designed to address those needs through a variability background across the Siemens Digital Industries software portfolio, which provides that single, consistent definition of product features, rules, and product content across your entire product definition and execution process. So highlighting a couple things along this slide here. So one is that for Teamcenter Product Configurator, Teamcenter is the backbone. So we built this configuration engine on top of this platform. So if we already have Teamcenter, it's a matter of just enabling it. So, and this can be any type of data. So we've separated the configurator, kind of the rules engine for the configurator, from the content. So that way this configuration can be applied to systems engineering data, design data, bill of processes, bill of material, manufacturing BOMs, any type of a BOM, if you will, any type of bill of material, whatever it is. You can apply that same consistent configuration to it. Now, visualization comes with it. So that allows you to help validate early in the process, check for collisions, interference, and also just see, well, what does this thing look like? So if this is a configuration, what does it look like? There's analytics, so like change and impact analysis. So all the data is under change control. So not only the part and the component data, but also the variability as well. So the features that go in it, those have a life cycle as well. On the lower left, product defined by planning. So you can define those sets of features at a corporate level, and that we can come through and reuse them throughout your various product lines. And you can see what happens if you change a feature on a platform. What would that impact be to other platforms? So maybe we're going to take a feature and no longer offer it. What products does that impact? And related to this webinar the whole series of webinars we've had on the management of multi-domain information. So Configurator works on data stored inside Teamcenter, but also can be work on data stored outside of Teamcenter, like Mentor and Polarian. So be able to manage that mechanical, the electrical, and the software. And then finally, seamless support. So we talked on the previous slide how there's configured order and there's engineered order. Sometimes there's a little blend in between there. Maybe most of the product is a configuration, but other ones, maybe there does need to be some engineering done to solve a couple requirements. So we have seamless support across configured order and engineered order. So you can call a rule stream ETO process and create new parts, for example. So Teamcenter Product Configurator, rule stream work together. All right, those are some of the features. As I indicated, so with Teamcenter Product Configurator, that variability definition is separated from the content. So this separation ensures that the variability in those rule definitions can be applied to multiple structures, so across multiple domains. So that same variability structure can be provided to the requirements, because the requirements may differ based upon the configuration of the product. The system definition, the design, the engineering, the manufacturing, and the service. Because obviously the manufacturing of the product could differ based upon the configuration. Maybe the assembly process or the inspection process may differ based upon if it's configuration 1 or configuration 2 of the product. So we're able to define that configuration once and then apply it to all the necessary structures that it needs to be applied to. We'll see an example of that later on. And like I mentioned, that variability also has its own life cycle. So in addition to the typical products, the P and PLM, product lifecycle management, the variability has its own life cycle as well. So it can go through change control processes. You can do impact analysis across those features to understand, well, where is this feature used, and so forth. All right, from a usability standpoint, so Teamcenter has a role-based UI. So we have a role-based UI where authors need a more sophisticated user interface compared to maybe an engineer who's just doing, just needs to go through and configure the structure to perform the various engineering tasks. And so an example we have on the left is more from a grid-based rule authoring. So it's for defining combination of features to select certain parts in an easy manner. We'll see an example of that later on in a video that shows some of this in action. And on the right side, more from a configuration standpoint. So engineers have their product content, their bill of material, whatever that may be, bill of material, a bill of process, MBOM, whatever. They also have the visualization that corresponds to it, so they can see what that bill of material looks like. And there's a configuration right there. So that we can come through and configure that structure based upon those features to, in essence, solve that BOM from 150% down to 100% to see what that configuration looks like. Or maybe you're comparing two different configurations because you want to know the similarities or differences between them. So we provide a role-based UI for ease of use by the user. Now, some benefits of Teamcenter Product Configurator. So one, product variability brought to the forefront. So we bring that variability management to very early in the process. So we're not doing it down the ERP side, bring it up into PLM. So everybody has access to it, and we can hand it off to ERP for here's a configuration of this, here's a configuration of that. So now when building feature breakdown of the product, you can start building up that product configuration, those features inside of your product early on. Start validating them and using them and solving them. And likewise, they also have their own life cycle as well. What I just indicated about validating, visualization. Visualization helps to validate those results early. Does that even look right? Do those parts fit together? Is this an acceptable configuration? Managing those configurations. What happens if you change a feature? What are the affected products? What locations around the world are affected? So we have that traceability and that impact analysis across all configurations. And then also the digital twin. So one benefit of having that configuration inside PLM is it's built for building that digital twin of geometry and electronic and PC boards and software and manufacturing. We get an exact representation of what the physical product would be in a digital environment. Now we can come through and do our analysis, our validation, our planning, and so forth. So ultimately, all right, so why Teamcenter Product Configurator? Sort of what I just said. So it's integrated, seamless interaction across Teamcenter domains. It's scalable, so it's ability to handle any level of product complexity. And so it's actually built on a microservice framework. So I mentioned earlier we can use it for not only information inside Teamcenter, but also for processes that are typically outside of a PLM domain. It's visual, always able to validate, always have that visualization. Visualization kind of comes along for free, if you will. So you solve the BOM, you can come through and visualize what that BOM looks like. It's role-focused, so author is able to manage the complexity, engineer is able to apply the configurations to focus on their particular related tasks. And it's informative, getting that right information in front of the user at the right time. And ultimately, as I mentioned earlier, we already have Teamcenter in place and deployed. There's no additional infrastructure that you need. It's basically just enabling this product configurator. So you don't have to come through and install a whole bunch of new servers and so forth. You can leverage the investments that you already have. All right, well, we'll talk a little bit about what configuration is and some of the different levels, the ETO and the CTO and variant matrix and Teamcenter Product Configurator and rule stream. Let's look at a couple of examples now. So we'll look at 3 or 4 different examples here. So the first one we'll look at will be the variant matrix. And remember, this was over towards the left side of that screen that I showed earlier, where you're more or less just determining, does the part go into this configuration, does the part not go into this configuration? So this is not for where they're setting up rules that says, well, if you pick X and then you pick Y and this is greater than 5, then you need this component, or you need 5 of those. It's mainly just, here's this product variant that we have, here's the parts that could be in there, which ones are in there. So there's really no rules that you're authoring for doing a variant matrix. So it gives you a grid-style matrix authoring. You can see an example on the right where you more or less have, well, here's a camera model, maybe an entry-level camera model, enthusiast level, and a pro model. Then it's just a matter of determining, well, what comes with it. So what comes with it? If you get the enthusiast model, you get 2 32 gigabit cards, where the entry level only comes with 1. Or the pro level comes with 228 gig cards. So it's mainly just what comes with it. So you're able to manage multiple BOMs in one view. There's no configuration rules involved. These are perfect for products with not a whole bunch of variants. Maybe 5, 10, 20, maybe up to 100. And like I said, no rules. It's mainly just is the part included or is the part not. So let's look at an example of this. We'll see a video of it. So in this video, you can see on the left here, there's multiple different body types. So this is for a camera. So different camera offerings that you have. So it's different body types, maybe some different battery packs, some different lenses, and some batteries. And so what you need to do as the owner of this configuration is first go add a new part to it. Maybe there's a new offering and have a new battery they're going to add to it. And then you have to choose which products get this battery. All right, then go and add a new product to it. Maybe there's a new product they're going to start selling and determine what components make up that product. And then you'll also look at some of the validation. So, all right, so in this example, you're going to go over the variant matrix, and that'll give you, like I said, that grid-style authoring, that user interface that allows for the ease of maintenance, typically replace a spreadsheet. A lot of customers would do this inside Excel. And the first thing you're going to do is go add a part. So like I mentioned, there's a battery that you need to add. So there's a new battery they're going to offer. And so now this battery gets added, and there's that new battery. And now you need to go to and edit your matrix to determine, well, what product actually gets the battery. So across the top here, you have all these different products. You have what, a Japan body only, America's type A, China type B, a couple different product examples. And then as you can see in the matrix, it's just a matter of, well, do you get this part or do you not? And in this example, the quantity is only one, but you could have multiple quantities for that particular component. So you're going to go determine with the battery type, which products get that battery. And maybe it's what the wildlife model for the Americas and the German type A, and it looks like the Japan travel type B. And you'll save that. And there you go. There's your variant authoring. And these are individual bombs which have their own life cycle. So these are physical bombs. It's not just a matrix you can look at. You can open up that bomb and take a look at it. Well, now maybe you need to add a new product. So in this example, you're creating a new product, a Japan wildlife type A camera. And now once again, so it's just a matter of, well, what components come with that camera. And one thing you do with the variant matrix is start with an existing configuration as the basis for your new one. So maybe that gets you 90% of what you need. Then you go through and just make the adjustments. Or maybe instead of this particular camera body, you're getting this other camera body. And so that's it. That's the variant matrix. Very easy to come through and use. You can show and maintain all your variants of a product in one central view. You also have the ability to filter. So all the different attributes and so forth that you can filter by. In this example, you're going to filter by Asia Pacific. See maybe what are the offerings you have in that particular area. You also have some built-in validation, which can come through and determine, hey, wait a minute, you've got these couple products here that have the same exact configuration. And maybe that's what you want. Maybe you need to track them differently. But this also gives you the option to reduce some overlap, reduce those number of SKUs or SKUs that you have out there because it's the same exact configuration. All right, so this is an example of a variant matrix. And like I said, those variants are individual bombs that have their own life cycle. And you got a nice, easy interface you can use to come through and maintain them. Well, now let's look at an example for configured order. So this gets a little more complex, I'd say. Not super complex, but here you have a hand drill. And maybe this hand drill you offered in a few different models. Maybe a consumer model, semi-professional model, and a professional model. And each one of those has different default features, kind of base features or standard features. Here's what comes with it. But then there's some configuration that you can come through and do. So maybe, for example, the professional, you're allowed to configure the left-hand or right-hand rotation. Where on the professional model, maybe you've got whether you want electronic speed control. Now, this is a little more complex than just saying, is this included or is this not? Because you've got lots of different features that may control it. Well, if you select the consumer model, you can't get the electronic speed control. But if you select the professional model, you can get the electronic speed control. There's some rules and some constraints that need to be defined behind the scenes. And that's where that Teamcenter product configurator comes into play. You can define that and then apply it to our particular structures. Well, what about from a manufacturing bill of materials? So this defines the engineering bill of materials. Well, what about when we go to manufacture it? We're going to have that same variability in there. And what about the bill of process? Well, that's where, since we separated that configurator out from the content, in essence, separated out from the BOM, it's separate. We can come through and define that configuration and then apply it to those different structures. So in this example, here's our configuration for the hand drill up top, and we can apply it to the E-BOM, that 150% E-BOM. Here's a configuration for it. Here's what it takes to solve 100% bombs of that. The M-BOM is going to be typically structured a little bit differently due to local regulations or government rules or maybe some ERP systems. But that engineering structure can be consolidated in M-BOM, and these linked structures can be kept in sync with each other. And that's due to being able to share that same exact configuration context. Same thing with the bill process. Typically, you define that tree or that BOM information in the form of an assembly line, or maybe the stations or operations that are in the plant floor where it's being assembled. And you'll consume parts from the BOM at the appropriate operation where those things are assembled together. Well, same thing. So from those 150% structures with a configurator, you can set those required features and options and get 100% configured EBOM, NBOM, envelope process all in one go. So you can see across the bottom, here's our different solve for the consumer and the professional models, and obviously a semi-professional model as well, but we can all solve those directly from that one single bill of material. Now let's look at that in action. So here will be a simple configuration where different choices lead to another choice. And so here you can see this bill of material, this 150% BOM, has a few different battery options. There's a couple different housings as far as the housing that covers the drill, a couple different motors and some electrical wiring. And so here's our 150% BOM. So using the configurator, the Teamcenter product configurator, so you can go in and pick what's known as a variant rule. And in this example, there may be some save variant rules. Maybe there's some common offerings that you have, or there's always some configurations that you're always configuring. Those can be saved off. That we can very quickly get to those configurations. So in this first example here, you're just going to pick from a save configuration. And so what that'll do is come through and solve the bill of materials, solve that BOM. So here's your 100% BOM. So it's this battery pack, it's this motor, it's this housing that goes with that particular configuration. And since visualization comes along for the ride, you can come through and easily visualize and interact with that product. So get a feel for what it looks like, turn components on and off, measurements, sections, clearance analysis, whatever you typically need to do to validate that particular design. Now in another example, let's set this back to default here. So now we're back at 150% BOM. Is this time you're going to go through and configure something. So now here's where you're presented with the various options. And these options are pretty simple. It's do you want this option or do you not? Now, as you go through here, some of these choices, if you make a choice for a particular motor, that may limit what other choices you have. So maybe because you go with the DC motor, that means you can't get an electronic speed control. But if you go with the brushless motor, maybe you can get the electronic speed control. So those are some of those constraints that we model based upon how you went off your configurations to configure your product. So in this example, you go through and pick the motor type and the spindle and the status light indication and the battery, and some of these choices are made for you based upon previous selections. Some of the choices go away. And ultimately, you have what your configuration is going to be. So you got what, the brushless DC motor and the 18-volt battery and the LED work light, and you do have electronic torque control. And so now when this BOM is solved, when you configure that BOM, here's that BOM would look like. So it's this battery pack, it's this housing, it's this motor, and so forth. And once you get into the visualization, you can see what it looks like. And in this example, there's a few more electronics in there. So there's a PC board, and there's probably some software in there that controls. So when you push the trigger, what does that do to determine sending the necessary information to the board, which controls the motor, and so forth. So that was one example. Well, let's look at still another example of a product configurator. So this example is a model machine, and this gets even a little bit more complex. So I'll start the video here so we can get to where it's at. But it is a model machine that has many different ways that this product can be configured. And there's some rules that are put in there to determine what that configuration is going to be. Well, if we stop here at the 150% configuration, and there's most of these components under the subassembly, it looks like a small assembly, but it's actually fairly large. There's lots of different choices here. So there's screens on both sides, the left-hand and right-hand side. There's a conveyor, and there's many different ways that conveyor can be configured, whether it bends forward or bends backward or is kind of straight. So there's lots of different configurations of what this conveyor looks like. There's a couple HMIs. So there's one on the left, one on the right, and the position of those is determine what the conveyor looks like. So if that conveyor is bent forward, it's a little tough to have this conveyor right here. It'll collide into each other. So I have a little different angle on that particular HMI. And not shown very well here, but there's also some different door choices as well as far as what that door needs to look like. So in essence, right now you have 150% BOM, and you're able to visualize what that 150% BOM looks like. You can't build this thing because you can't have two parts occupy the same space. But through the use of Teamcenter Product Configurator, let's go into that variant configuration, and we'll actually turn on the full screen variant configuration. So you can use the full screen for here. So you've got some different feature sets here, but you also have a couple different product lines. Now, before we pick one of these models, we'll visit the functions. So under functions, there's about 6 different functions here. So whether you want that feeder to bend to the front or bend to the rear or straight, I think I was calling it a conveyor, but I guess it's a feeder. The height adjustment, the line machine mode, there's about 6 different choices that you have here. Now, once again, with the product configurator, there may be some constraints behind the scenes that determines, well, when do you actually get to pick these? Because there might be certain configurations where it's always a bend to front, or it's always a straight, or whatever it may be. Well, let's see an example of that. So there are 6 possible choices under function, but here you're going to start, wait till it's actually selected, you're going to start with this V2000 model. Now, based upon that, that could determine what your other configuration choices are. So maybe the V2000 is maybe lower end, maybe there's not as much variability that we offer. Or maybe the Z3000 maybe has a lot more variability. So there were 6 different possible things to configure under functions. But since you selected the V2000, now you go under functions, 2 choices. So because of that model, some of those constraints, some of those rules, it eliminated some of the configuration possibilities for that particular model. So now you're limited just, well, does it bend to the front or rear, or is it straight? So you'll come through, make that configuration, you determine you need a straight feeder. Maybe there's a couple of look and feel where you want that HMI to be positioned, and some of the signal lamps and the doors. I'll go out of the full screen configure interface so we can actually watch the BOM configure. So here you can see multiple doors here. You have the basic door, the intermediate, and the professional. And so based upon you selecting the single door and the single front shield door, once this is configured, this BOM will solve from 150% BOM down to 100%. And here's what that solved BOM would look like with these particular options. Now you can save those configurations. We saw that in the drill, there's that drop-down menu where you to pick from some saved configurations. So if you're authorized, you can come through and save one of those off. Maybe there's a popular configuration that you need. That we can very easily load those in the future so that we don't have to go through all those choices. A lot of times there could be hundreds of options that you have to go through and configure. Where having that saved configuration allows you to quickly get back to those saved configurations. All right, so here's the result of that 100% BOM. So if you remember what this screen looked like before, had a bunch of conveyors all over the place, had a bunch of conveyor options, had a bunch of HMIs sticking off there, had a bunch of screens left and right. So now we've solved that 100% BOM for what I think it was like the V2000 with the straight feeder and the single something door. Here's what that particular BOM looks like. And likewise, the same configuration, those same rule sets and features could be applied to the MBOM, or the bill of process, and even the requirements and so forth. All right, so we've taken a look a little bit about what the configuration, what the possible different variability offerings are. So the variant matrix, the rule stream, Teamcenter product configurator, talk about some of the benefits along the way, saw some of that in action, saw some live videos so we could see that in action. We've got a couple proof points here. So one is for Geely. Geely is an automotive manufacturer. So they've been around since 1986, and they entered the automotive industry in 1997. And they sell passenger cars and commercial vehicles under a variety of different brands. You've probably heard of some of them in addition to Geely. And so last year they sold over 1.5 million vehicles. And so the quote here from the Vice President is that we needed everyone to be able to see the same information at the same time. And Teamcenter Product Configurators enabled us to do that. So by having that configuration information early up front, everybody along that whole value chain come through and see it. So systems engineering, design, manufacturing, production, service, and so forth, all have access to that same exact information to be able to configure and solve the BOM in the same way. Another one, Kona Cranes, which specialize in the manufacture and service of cranes and lifting equipment. And these are typically for industries where there's handling heavy loads. So like shipping ports or terminals and shipyards and so forth. And so their quote here is, they're now implementing Teamcenter Product Configurator. It's closer to the product data, and it offers more features compared to other product configurators, which are quite commonly ERP focused. So you got all that stuff down on the ERP side. You don't have the ability to do the stuff we've been talking about today. Early on configuration, the visualization, solving for very complex products, common interaction throughout that whole value chain. And so the results, Streamline mass produced to custom products. So they're able to get more customized and introduce more availability to solve the particular customer needs, as opposed to just one-off mass-produced needs. Reduce the workload with one configuration model, not maintaining multiple different bonds, and that single source of data for engineering, manufacturing, procurement, and service. Even CIMdata. So CIMdata endorses our configuration solution suite. They actually have some commentary you can get on their site. And they more or less say, if you read some of these quotes, although we're not going to study these all day, is they believe that Siemens has demonstrated they understand the evolving needs of their customers and the key role that world-class configurator solution plays in supporting the increasingly complex multi-domain products these customers produce and deliver to their customers. And as we talked about, we have a full spectrum of solutions all the way from CTO all the way through ETO, and they can each work together as well. All right, so earlier I put up this need slide. Said if you're looking for something, here's some of the things you need from a variability management standpoint. And so we more or less, Teamcenter Product Configurator checks all those boxes. So addressing those ever-increasing pressure to offer greater choice and variety in the products to meet those customer expectations, Teamcenter Product Configurator enables manufacturers to specialize a product to their specific needs. So using that CTO, that configured order approach, which brings product specialization closer to the customer. So using traditional processes, configured order can overwhelm resources with duplicated data. That's probably what you're facing today. So Teamcenter Product Configurator help you deliver that single variant management, that backbone that resides on Teamcenter, that makes certain all the disciplines are working from a common understanding of product configurability. All right, so we've spent a lot of time talking about variability and the importance of it, be able to manage all that information. So you combine that with the importance of integrating mechanical, electronic, software, and simulation data into a single collaborative environment. This is going to help you drive those engineering productivity and product innovation across the enterprise. Basically, a path forward for greater product innovation and greater overall business performance. Now that you've seen our software solutions, so we're around to help. So we've got a global network of partners. As Sarah mentioned at the beginning, we're all over the place. We've got a large workforce throughout the world. Probably have a location and some people nearby that can help you understand what your business challenges are and help you on the path to solutions for those business challenges. And with that, I want to thank you for attending. As I mentioned earlier, this is part of a series of webinars. So if you want to continue this webinar series and learn more strategies to streamline your product innovation, at the website on there, siemens.com/teamcenter. And it's called the See the Impact of PLM webinar series. And as I mentioned, this is the 5th one of 6 that we've been doing live. So we'll do the next one next month. You can go through and sign up for it. But you can also view the other ones that we've already delivered on demand at a time that's convenient for you. And so with that, I'd like to hand it back to Sarah.
This officially concludes today's webinar. Thanks again for joining us, and have a great rest of your day.